Hey everybody, this is your 6-3 Math Excel video, and it's more graphing, specifically graphing the square root function. So on the first one, it's a multiple choice graph. You want to use a table if you have to, whether it's a table on paper or calculator. So very similar to what we've been doing. The main thing is just pay attention to your transformation. So on mine, I had y equal the square root of x and then plus 4 to the side, so that meant up. And on the next one, same idea. This was the square root of x minus 5, and the negative 5 was underneath the square root, so that means it goes right. And then this time, the plus 5 is under the square root, so that goes left. And this time there's a number in front, so that's a vertical stretch. So that's how you do the first several. On the next one, what you do is look at what you have in front. I have a 1/3 square root of x on mine, so that means it's a vertical compression, so it's a little bit shorter. And there are two parts on this one. You have to pick the description. It has check boxes, but only use one check box for vertical compression on that one. If you have a 1 over something or something smaller than 1. The next one, you have a square root of 5x, and the 5 is underneath the square root, so that would be a compression horizontally by 5. So again, pick your graph and pick your description. The next one has a couple of parts. You have, at least on mine, a 3 in front and a plus 4 underneath the square root. So that means a vertical stretch by 3 and then left 4. Because like we said earlier, plus 4 when it's underneath here means left 4. Okay, now you have a word problem. And on this one, it says a company makes steel food cans of different sizes. All of them are 9 centimeters tall. I saw another one said 11 centimeters tall. That part just changes. But it says the radii vary. So basically some of them are thicker than others, but they're the same height. And then everybody's going to have a different equation. In mine, it's r equal 0.19 square root of v. So the r is your radius, and it's the radius based on the volume. So the first thing they want to do is describe the transformation, and since this number is less than 1, it's a vertical compression. And then the next one says, given a volume, find the radius, and mine said 600 cubic centimeters, so 600 centimeters cubed. So all you do is 0.19 times the square root of 600, and they want you to round this one to the 100th, which means 2 decimal places, and so that'd be 4.65 in my case. And then the next part you can do, it just says explain how you can check your answer if it's reasonable. The next one says, given the graph, what is the function? This is one of the harder ones, but I couldn't graph this on my paper here, and so you might want to look at an example on this one. It says y equal the square root, a in front, a times the square root of bx minus c and then plus d. That's your general formula for it with your a, b, c, and d. So what you want to do is think about the transformations, including where the minimum is, and is it left or right, is it up or down, and is it a stretch or compress. And it could be multiple things. Now, substitute a point in when you're finding the vertical stretch if it isn't just like based on the typical square root of x parent function. And again, you can guess and check on the calculator with different points to compare your tables, compare your values of it. And the example was 4 square root of x plus 5 and then minus 7, which meant a vertical stretch of 4, left 5, and down 7. So use that as an example and look through how yours changes from the original. Okay, the next one says rewrite the function to make it easy to graph. And we have the square root of 49x minus 98 and then minus 8. So when it said rewrite the function, I was like, well, what's our greatest common factor? What's our greatest common factor? GCF. Do we factor out a 7? You could, but then you'd have to keep on going in my case because both of these are divisible by 49. So 49 goes. So when you do that, you have the square root 49 times x minus 2, because 2 times 49 is 98. And then you bring down the minus 8. So then you put the square root of 49 part in front, so you get 7 square root of x minus 2 minus 8. And then the difference is, this is your vertex form of it. Just like earlier we were talking about your standard form with your A, B, C, and D. So this is your vertex form, so that means you have your vertical stretch of 7. You're going right 2 because the minus 2, which is underneath, goes to the side. It's right 2. And then the minus 8 is down 8. Okay, the last one, it's a word problem, and it says the size of the screen for an electronic device like a TV is given as the length of the diagonal in inches. The equation given in my problem was D equal to 7/8 times the square root of 2A, where A is the area. So the first thing you want to do is graph it on the calculator, and there's multiple choice, and just set your window appropriately where you don't have negatives, because you can't have negative area or negative inches for your diagonal. Then the next one says, suppose you want one that's twice the area. So not just twice the diagonal, but twice the area. So given my original was 35 inches, what is the new? So we first want to graph it, and then we want to put F2 equal to 35. So F1 would be 7/8 square root of 2x. And then F2 would be 35. Make sure you move your window out far enough and find the x coordinate of your intersection, because we already know your y coordinate would be 35. So it's something, comma, 35. And when you do that, in my case, I'd find out that it's 800. So that's the original area. So you have to move it out quite a bit until it hits. So 800 square inches is the original area. So then you want to multiply by 2 and then put it in the equation. So 800 times 2 is 1600, and then you put that into your equation. So 7/8, the square root of 2 times 1600. So it's like making it times 4, if you want to think of it that way, and then the square root of that, and then times 7/8. And in this case, I get 49.5 inches. So that'd be my diagonal. All right, hope that helps.